Unit 6, Lesson 5. We have gone over the 3 ways to factor completely. Always check GCF first. Then if there's 2 terms with subtraction, see if you have the difference of 2 perfect squares. If you have a trinomial and your A term is 1, you want to try your reverse box method. Or if the A term is greater than 1, remember we are using arcing. The method that we use today that we're going to see is very similar to arcing. So if you need some review on arcing, go back and watch the previous lesson. We want to exercise 1. Factor a binomial common factor out of each of the following expressions. Write your final answer as an expression of the product of 2 binomials. So in A, you can see that we have 2 separate terms, much like we did when we did our arcing. And they have a common binomial that you take out. So 2x plus 1 times x plus 7. And that is all they want you to do. So it does help that we follow the arcing method. And this particular problem could be a part 1 question or a part 2 question worth 2 points. So part B, take out the x minus 2. You're left with a 5x minus 4. Now the next one, you have the x minus 7 that you take out, but I also have an x plus 5 plus x plus 1. So there's 2 more binomials that you will need to combine. So then we have x minus 7, and then it's 2x plus 6. Final one, letter D, you take out the x plus 4. Be very careful because this one is subtraction. And we have 2x plus 8 minus x minus 2, which would become 2x plus 8 minus x plus 2. So then we have x plus 4, and then x plus 10. In exercise 2, we want to validate that this is true. So write the expression as the equivalent product of binomials. Take out the x plus 3. So I have x plus 3, and then it's x minus 4 plus 5. You see, I don't put the parentheses in when you have addition of the 2 terms because you don't need to change any of the signs. So then we have x plus 3 and x plus 1. And when it says test the equivalency with x equals to 2, you would do your such that x equals 2, and you would do the same for the original. Do your such that x equals 2, and make sure it works. And when you plug it into your calculator, you should get 15 for both of them. Okay, in exercise 3, we want to justify each step below with one of the 3 major properties of real numbers: commutative, associative, distributive. I still have seen this on some of the exams, maybe as a part 1. Very rarely will we see it at this level as a part 2, but who knows. With the first step, so here's your original polynomial. What you are doing is grouping them. Okay, so when you're grouping them, it is the associative property. And then what you are doing in the second one, you are factoring out, and another method of factoring is also the distributive property. And the last step, you are also factoring out the x minus 3. So this is also a distributive property. Okay, now there is one additional method to use for factoring. It's called factor by grouping. And you want to try factor by grouping when you have 4 terms So if I have 4 terms, usually the highest term will be an x cubed. Not always, but usually it is for now. So method by grouping, again, it's just like arcing. You group the first two, you group the second two. Take out the GCF, which is an x squared. I'm left with 3x plus 2. And then what do we want here? We want 3x plus 2 again. So that means I can take out a negative 9. So I have 3x plus 2, and then x squared minus 9. Now, what it says in the original directions is completely factor. So once you have this started and you did your grouping, you want to make sure that you look at the two binomials, the 3x plus 2, x squared minus 9. You cannot take a GCF out. Is there a difference of two perfect squares? Yes, there is. X squared minus 9. So I have a 3x plus 2 times x plus 3 times x minus 3. And that's completely factored. Letter B, group the first two, group the second two. I take out the GCF, which is 9x squared. I'm left with 2x plus 1. I need to have a 2x plus 1, or it's not going to work. So therefore, I factor out a negative 1. So then I have 2x plus 1 times 9x squared minus 1. Again, no other GCF. Look for difference of two perfect squares. 2x plus 1, there is no difference of two perfect squares. But 9x squared minus 1 is a difference of two perfect squares. It breaks down to 3x plus 1, 3x minus 1. And that is factored completely. It does not always have to factor further. Sometimes it does. Letter C, group the first two, group the second two. Now, if you notice in this one, the highest power is x to the 5th. Okay, like I said, which could happen. So follow the same process. And you want to take out an x cubed. So I'm left with an x squared plus 4. So I am hoping this is going to be left with an x squared plus 4. And sure enough, I take out a plus 2. So I have an x squared plus 4 and x cubed plus 2. No GCF to take out, but look and see if you can do a difference of two perfect squares. You need to be very careful because this x squared plus 4, x squared is a perfect square, 4 is a perfect square, but it is not the difference. There's no subtraction, so that's as far as you can go. One thing I don't think I mentioned yet is just make sure your original polynomial is in descending order, highest exponent to lowest. Now, if you look at letter D, you can notice that there is a 5 that I can take out of every single term. There's your GCF. Right, so if I take a 5 out, I'm left with x cubed plus 2x squared plus 4x plus 8. Right, so remember, you look for the GCF first. If you didn't see it first, you could see it at the end. Follow the same process. Group the first two, group the second two. Take out an x squared. I have an x plus 2. Take out a 4. I'm left with an x plus 2. Don't forget the 5. So then I have x plus 2, x squared plus 4, and then bring down the 5. Because still, these are expressions. We're going to deal with equations later on this week. Okay. If there's any questions, anything you're confused on, rewind it, play it again, so you can see what's going on. Consider the expression x squared plus ab minus ax minus bx. How can you rewrite the expression so that the first two terms share a common factor other than 1? So if you look at these first two terms, it's an x squared plus ab. You cannot factor something out. So sometimes they'll give you variables. Right? So they're trying to find a rule. So if we want to rewrite it, okay, I have an x squared, I can do a minus ax plus ab minus bx. Now I'll be able to take out a common factor of the first two terms. Or I could write it as x squared minus bx plus ab minus ax. And I can take out an x again. Now, write this expression as an equivalent product of binomials. you can use either one. So if I use x squared minus ax plus ab minus bx, group the first two, group the second two. Take out the x, okay? And I am left with an x minus a. Take out, in the next one, this is where it's going to get a little tricky. I'm taking out a b, and it's an a minus x. So you can see there's a slight difference here. Okay? So slight difference would mean that, okay, I'm going to rewrite this as negative x plus a. Factor out a negative 1, I have an x minus a. So then this negative 1 gets multiplied by the b, and I would have x minus a, minus b, x minus a. So very tricky. So you have x minus a times x minus b. Okay? And those are rules. We'll look more with the variables as the course proceeds. And we'll see some as we prepare for the Regents exam. There's a lot of different ways that they can ask them. Be careful when you use factoring by grouping. Don't force this method when it does not apply. So they're showing you an example where it does not work. So if I look at the last exercise, 2x cubed plus 10x squared plus 7x plus 21, I group it. Okay, they grouped it here, and they took out the 2x squared, and you're left with an x plus 5, and then that's a 21. So you took out a 7, you're left with an x plus 3. So they want you to explain the error made in factoring. Well, we have nothing in common in these two terms. So unfortunately, that's all we can do. We have to stop there because we cannot take out this common term. Okay, so that's what you need to have. You need to have one of them in common. Otherwise, it will not work. And you can even see if you get to this last step down here, if you go to do the box method, okay, or double distribute, if I have 2x squared, okay, and I'm doing the 2x plus 8, so the 2x squared is going to give me 4x cubed. My 4x cubed does not match the 2x cubed. So that's another way you can do it. You can say, okay, let me check it and make sure it works. Okay, and it does not work. Okay, so that's it for lesson 5. It should be an easier lesson because of the arcing lesson. If you miss the arcing lesson, then it's going to be challenging. So just make sure you do keep up with the lessons, you keep up with the homework assignments, and check the answers and ask questions in class. All right, we'll see you in class. Beans.